Hello everyone, so in this video we will be looking into Kubernetes engines and we will be trying to deploy some application on GKE clusters so we can see our applications running. So we will be doing it from the scratch. So let's start. So this is one of the products available in GCP, and for me, for this particular project, Google Kubernetes Engine API is not enabled. So let's enable for this particular demo. It will take some time. So I think we are now ready, and this is our landing screen, get started screen, where it will allow us to create cluster workloads and all the other related services of Kubernetes Engine is available here. So first of all, I will be doing some basic setups, and then we will try to deploy one application in GKE that we can see running over here. Let's look into the clusters. So for us, we don't have any clusters for now. So we have to create cluster, and then in the cluster we have to deploy our application. I mean the container that contains our application, and maybe we can do some more configurations. We can do auto scaling and all other things. But let's start from the basics because understanding this GKE is very important because obviously like GKE provides a lot of services. I mean, you name it and it has it. So, I mean, learning it from every service point of view will take very much time, but for particular this particular course and generally focusing on our exams, we will try to see some basic things here. Okay. And in later, maybe in some other playlist or maybe some other video, I will try to, do the things end to end. So anyone who is trying to learn or maybe has some real world scenarios or has some project requirements, they can easily learn from that video. So let's focus on this limited and quite focused video. Let's move into the coding part and we will try to create something that can be deployed on GKE. So first of all, let's check for the cloud. So cloud SDK, and this is available with us. So let's do a init so we can initialize the settings. So it says, do you want to reinitiate this configuration default with new settings? So, or you want to create new one. So I think we have this South Asia one already done, setup is done, everything is done. Just we have to check the project thing. So do we have the same project? 307, is it same? No, we don't have this thing here. Okay, let's do one thing here. Let's create new configuration or let's pick one. So it will check for the configurations, check match the configuration, available configuration over there. So it will say, do you want with the existing one? So I want with the existing one. That's fine. Then it will ask for the project ID. So learning 246590. Do we have this? Yeah, we have this one. Let's move ahead with the one as well. And then it will ask for some other things. So you want to go for default compute region and zones. I would say yes. So what you prefer here? So I will prefer the one that was already there, like Asia South 1 and Asia South 1A. So I will choose Asia South 1. that will be, it says Asia South 1A. So Asia South 1A is 38. Let's pick 38. So I think we are good and settings are done. So I think we are pretty much good, and I think we are ready to go for other things. So let's do one more thing. Let's set up our. So let me, tell you what I did here. Maybe if you don't understand. So this is a shell, cloud shell that is used to, set some configurations, a basic configuration that this cloud CDK will utilize to, deploy your GKE, make some configurations. So you don't have to specify this your what project you are going to deploy, what will be your uh, default region zones. So these all are already been set and it will remember it till it's all deployments are done. So that's what I did. So now it's okay. Now we have to create a quick Python application here. So I will try to create an application here. Let's say py, and we'll just keep it simple. Yeah, let's do the Flask. So this is our sample app.py where we are using Flask to create a small REST application. We have this get request handler that is handling the anything that is coming after the first slash, and we have this hello function that will respond to any request coming to this particular URL. And then we have this initial loader where the application will be started at, or I would say it will be bootstrapped. So our app thing is done. Let's create one more file, that is a requirement.txt. So spelling of requirement is fine. I think REQUIREMENT. Yeah, that's correct. So our requirement.txt is also ready. We have this Flask with this version. We have the Unicorn with this version to run our Flask application. Let's create one Docker file. So this Docker file is very important because it will be something that will be used to, dictate the containers, like what kind of environments and what kind of, application and how it will be running inside that, GKE. So this is important. So we have this Docker file here. So let's start with some imports. So we have to add a basic uh, image. I will be taking it as Python 3. Yeah, yeah. Claim is added just to make sure like the our whatever the build and Docker file we are creating is will be of lightweight. So that's why we are using this thing. Now let's do one more thing. Let's play with the users. So I will be creating a non-root user. Okay, so I have created a user here. Now I'm setting my work directory. So my work directory will be dir will be app. It's something generally in named in every application. Maybe it's Python, maybe it's Java. Generally work directory is named like dash app. So this is where we will be installing everything. So first of all, we will copy the requirement file to this particular work directory. So requirements, require requirements dot txt. 1 minute, I did something wrong here. I have to rename it with, oh no, I don't have to delete, I have to rename it. Requirements, yeah, that's correct. So txt. Now we will be trying to install the requirement file, pip install, and some additional parameters. So it's not create cache as well. So it will not create cache for the installation. It will also help to make our uh, builds with lightweight. Okay. Now let's do one more thing. Let's copy everything to our current work directory. And right now I will be removing this user from the root. So it's done. Now we will be setting up the environment. And now we will expose our application to 8080 so it can be reached out by the outer world or outside the container. It will be exposed on port 8080. So the application is running on 8080 and it will be exposed outside the container using the port 8080. Let's write the command and we'll use the Gunicon to run our application in production. Generally, this is used to run applications in production. Then the next parameter B, then the IP and the port 8080, then app, app, sorry, it will create worker nodes of the application. I will mark it as 2, and also if you want you can provide threads. I want 4 threads. So this is how a Python application is deployed in production. So I think I have added almost every things that are required to deploy and run our application in this Docker file. Okay. So now let's do some CLI things so we can, create the clusters. So first of all, do one thing. We have to run some gcloud commands. So our first gcloud command will be gcloud container cluster create auto as we are using Autopilot, and it will be as let's say name it as Autopilot 1, Autopilot 1, and it will be in our, if it don't provide region, I think it already had the region, it will deploy in that the region where we have did the selections. So if I can do this, oh my bad, I have to use this thing so it can actually execute my commands. So what it says like invalid choice cluster. Why it's saying invalid choice? Oh, sorry, spelling mistake. So the kubectl read-only port is now deprecated. Yeah, that's a simple note. So right now it's doing some process, and actually it will be, try to create the cluster. So let's wait until it will create our cluster. Meanwhile, it's creating. Let's check if we have anything here. Let's refresh this. So you see, so let's see, this is our cluster that has been created. I mean, still been created. So let's wait. So great, we have our cluster is created, and these are some details provided related to the cluster that we have created. Let's see our cluster in the browser. So this is our cluster created, and if we go inside, these are some basic cluster informations, and no need to worry about all those things. You just need to worry about the regions that we have provided and name of the cluster. And now inside this cluster we will be deploying our application in the nodes and then in the pods. So we will be doing a YML configurations that will define the type of and the structure of our pods and our containers. So that's a different stage. Right now, let's connect with this cluster. Let's come back to our terminal. So let's first of all, we have to pull the credentials. So for pulling the credentials, we have to run this command container clusters. Then we have to get the credentials. Name of our cluster, pilot 1, and region will be default and project will also be default because we have already set that uh, while doing the initial configuration of this CLI. So I think we are good. Let's click on it and it will pull that for us. What says it was not able to find Autopilot 1. Yes. Oh, sorry. My bad. So I think I need to specify the region. It's somehow not able to identify the region. So let's do one thing. That region will be Asia, UT, Asia South 1. Let's do it. So I think we are ready. Then now, as we are having the credentials, we can do many other things in it. So let's do the next step, and that step is about uh, building the application. I mean, the building the Docker file, creating an image, and pushing that image to the artifact registry. So generally, when we are doing something in production on large scale, we use cloud build for this particular step. Okay, so we are skipping this and doing it using this command prompt. So let's start this and gcloud artifacts repositories. So we are creating one. So create a repo, and what should be the name of the repo? So let's name it as demo py. I think that's, and the repository format is of what type? It will be of Docker. So these are some commands you have to remember, and if you don't remember, maybe you can search it or keep it handy with you whenever you are working on it, because actually it's really not easy to remember these things, because we don't do these commands and don't run these commands daily, so it happens. That's not an issue. So Asia South 1, and the last thing will be the description. It's not mandatory, but you can provide it. Description will be, let's keep as my demo Python app. I think that's enough. So right now we're creating a repository in the artifact registry. So let's do this. And once this repository is created in the artifact registry, then we will be, pushing our build. So understand this like this, like you have to place your application, you have to place your build somewhere that your Kubernetes can pull later, or maybe while running, maybe some pod gets down or some failure happens, it can easily recreate using that image. So we have to push that image somewhere. So this repository is that place where we are pushing our, you know, our application, build of our application. Okay. So I think we are ready with our repository. Now let's push our builds. Let me do one thing. Let me provide the name of this image as Asia South. We are using Asia South 1 if I'm not wrong. Asia dash South 1. Okay, that's great. Asia. So now we're providing the tag and we'll provide the name of that image. So Asia dash South 1 dash Docker pkg dot dev dash. So what was the name of our project? So our project is learning, then the repo, the name of repo is, oh my bad. What was the name of the repo? The name of repo was demo py. Okay. uh, demo py bash. And keep the version as one. I think we are good with this. I and I'm sure we will be not getting any error for it. So let's do this thing. What says it says cannot find app. Why is it not able to find the app? Oh, my bad. I have to put it like this. So now it's running the Docker file, creating a build, and that build will then be deployed. Not deployed, but pushed into the uh, that repository. Okay. What it says like what is the error? Already have an image with digest. That's my Docker. Hmm. So there is some error with my Docker file. So let's check what's the issue. It says items line number 6 copy requires two. Okay, so it says copy requires two arguments, but only one provider destination could not be determined. Okay, I got this thing. So let's fix this. And it has to be like this. Means current directory. I think we are good again. Let's try to create the build again. So I was telling like this build will be pushed in the artifact registry, and later our GKE will pull this image and create our application. Now what's the issue? It says okay, it says daemon docker pass line 6 unknown instruction cmd unicorn go gu unicorn. I have this installed already, but why it says like this? Oh, my mistake here is the space. Okay. Now it's building the application. So we have our build deployed to the artifact registry. Let me show this to you as well. So let me search for the artifact registry. Artifact registry. This is the registry, and here is our uh, this build is right now sitting here. And when this Kubernetes will start creating the nodes and pods, it requires this build because this build has our code. We just pushed that here. So it will pull it from here and start running the application. And let's say if any go node goes down and there is any health issue, any connectivity issue with any pod or anything, it will destroy that pod and again create a new one. And this repo here, this repository where we have our image will help to create it once again. So that's the proper flow. Now we will try to create something. I said YML file, and this YML file is KTS YML file that has the configurations and all the details like how this cluster will create your uh, pods, how it will create the replicas. It contains all the details, and using those details, this cluster will pull the image and then according to that YML file configurations create the node and the pods subsequently. So let's do that. So we can do it like this. Let's create a folder and name it as KTS. KTS, what is KTS? So it's just an abbreviation of Kubernetes. K start Kubernetes start from K ends for S, and the rest letters between K and S are counted as 8, and so it's K8S. That's a slow. I don't know. That's a logic behind it. So let's create the K8S YAML. So there are multiple sample YML files could be found on Google documentations and all. But for our requirement, I have one already created because it's a lengthy process. So I have one created with me, and I will explain much of the portion of that so you can understand like what's happening inside that. So this is something I have created for you. So let's understand this YML file one by one. So first of all, this section right here, this one, it is something related to the Kubernetes API. So it did give you the information about like what version of Kubernetes API group you are using. Then it is something called namespace. So what type of information it is. So it's of namespace. And I mean, what is the name of your app? So you can put your name. For us, let's keep it as an app. So this information, so this is something related to our application. So again, that's something API version gives the details about uh, the Kubernetes app versions group. So it's apps.v1, nothing related to our application. It's related to KTS. But this kind deployment tells like what type of this whole configuration is. So this configuration is of deployment, so it contains the deployment informations, and this metadata information contains the name of your deployment. So I our deployment name could be kept as PyDemo, and this is the namespace like where it should be deployed. So namespace is app. So this app is referring to this metadata. So this namespace here is referring to this one. Okay. So that's all information, and this written right here information is about the deployment. So now this below part like spec is all about the specifications that we are going to use to deploy our application. So it says like how many pods you want to run. So here it says one. So your every node has one pod running. If you make it two, then you will see two pods running. Okay, so let's make it two for now. So you can see like how this specification takes place. I mean, how this has a specification, affect your deployments. Now, the next thing is selector. So, it tells the deployment like which pod belongs to it, like by matching the label app. So right now it says py demo. So it understand like, okay, so my metadata is here, and this is something I have to do. So it knows what deployment it has to do. So it's just a matching of labels, and it understand like what metadata we have. So right now we have this py demo. So this app understand like, yeah, this is something for this namespace and this specification I have to do this this deployment. Now the next part is template. So this template actually is been attached to each pod. So each pod will contain a label, and that label name will be PyDemo. So it will be easy to find any deployment inside the you know container and other deployment things. So that's something help you to identify your pod. So now we have reached to the section where we will be what providing what details are required by container to create a container. So first of all, we will be providing the name of the container, that is web. Then what image it has to pull. So we will be putting our image name here. So let's go and look for our image name. So our image name, let me open this. So this is the name of image. Let's copy this image here and paste this here. So we have our image name provided, and now this pod knows with this label like what image it has to create. Now this is the port where our container will run. So that's obviously 8080. Now this is something related to uh, Kubernetes internal things, like it will use this for readiness to check like our pod is ready to serve the services. It check for if our pod is actually running or not. So these are some settings that defines how pod will respond and how pod will be checked internally by the Kubernetes services. Can be a uh, control manager, can be any other master node can use these things to plan the node, plan the pods, or create replicas. So this is something how it works. This is the type of configuration, like what will be the CPU, what will be the memory of the pod. Okay, so this is something important. Now the other section is related to the service. So this one was related to the deployment. Okay, so you understand this was the kind of deployment. This configurations was for the deployment, and now this configuration here is related to the service. So what is this service? So this service is all about uh, the something that is exposed outside the pod. So so this information is all about a service uh, that is exposed. Uh, this information is all about a service that has been exposed inside a pod, or maybe outside the pod or the cluster, so that this pod can serve the request. So this information is all about that. So here again, this is the metadata, the name of this particular a service for which it has been doing this. Namespace is again the app. Write this right here, and then we have the selector. So the selector is again just to identify or search your service in the list of multiple services. This load balancer is something we are providing, like how GKE, like Kubernetes Engine, will create a Google Cloud external load balancer. So this will be used for creating the load balancers, you know. So I think this is all about the load balancing thing. Then the ports, like on what ports and where it will be running. So this is something important too. put here. You can change it as per your requirement. So this is something, all the configurations we require to run our sample Python application. So I think we are good with the YML file. We understood it. Now let's deploy this Python. Uh, let's use this YML file to actually create nodes and pods inside the cluster. So to do this, we have to run such some commands here. So let's try this thing here and let's try to create something inside the cluster. Cuttle apply dash f k a dash k dash, and inside we have the kdash.yml. So let's keep as kdash.yml. I think that's all we need to do here. So it says something related to error validating there, error validating data failed to download API. Okay. Credentials. It looks like you're trying to client Google credentials plugin is not installed. Okay, okay, okay. So I have to do one more thing. So it says like we don't have this auth plugin. So let's try to install it. So let's use this G Cloud service components and install this thing here. I think this will solve our issue. I think yes. So I think it's done. And now we have to do this once again. Let's try once more. Let's see what happens. I think it has deployed our services, but we have to check it. So to check like whatever we have deployed is actually running or not, let's try to see one thing here. Let's try to check for the IPs slow. So until we get, so we don't have the external IPs right now, but we can check into our GCP portal if this cluster and its pods are running or not. So let's go to the cluster thing. We already have our cluster. I think, yeah, we have our cluster, and this cluster is also fine, and we have all these informations related to this cluster. Now let's do one thing. Let's go to the workloads. So this workload will, give the details of what's running inside this cluster. So we have this PyDemo inside our cluster, and it has two pods and the namespaces app. These are all informations that we have already seen in our YML file, if you remember. So let's open this py.demo. So these are some monitoring things where you can monitor your pods. Let's go and see the pods. So these are two pods running. inside this pure demo, and let's see something more if that is relevant for our deployment. So these are some, informations that will be useful if you have to debug or understand if there is anything wrong. But for now, it's important to see like we have our pods running here, and we have two replicas defined here. So we see we have two replicas, so two pods are running here. That's what we expected. And we have this URL where our application is running. So if I can click on it, so we will be seeing our hi. This is a sample app of GKE using Autopilot. So this portal is live and running on GKE. Okay, so that's how it's working. I have to show you some other things as well. So I will go one by one. So we have seen the cluster, we have seen our workloads. Now, the things that is to be, taken consideration where we have been deploying some very secure applications and we have some secrets, some configuration details. So we can keep all these informations here in the secret and config session. This is the storage. If you have some uh, volumes that you want to attach with the pods to keep some data consistent, even though your, a pod goes down, so you can use this section here. These are some other information, but gateway and services are something that is used when you are trying to create something that is communicating with any other, you know, GKE service or any kind of infrastructure you are creating that consists of multiple Kubernetes services, then this section is used. And other than this, these are some features like service mesh that helps you to connect with on-premise or any other uh, GKE service or any other service that is running. So these are some other features that can be used, but for the overview perspective, this is how things works in our GKE. So I think for now we are kind of okay with the information that I have provided you, and many other options and features available here that you can explore. But for now, this is our website running inside GK cluster. Further, I will try to automate two things, and I will create a separate video on that. The first one is the build that we did via our command prompt. That build which post your application to repository, artifact repository. And the another thing that we did was deploying of this K8s YML, and then your image was pulled in and then the pod was created. So these are two things, and these two things will be automated using Google Cloud Build and Google Cloud Deploy. So these two things I will also, try to explain and create a demo video. Although these two services of Google Cloud is not so important from exam perspective, but to learning and to explore the things, it's important to understand this. So I will try to create that video as well. So thank you for watching this video, and I think this video was quite informative for you, and I request you to please subscribe my channel, like this video, share my video. As I'm a working professional and I have to sit and spend time to create these videos, so these likes, comments, and the subscriptions that you do motivates me. so that I'm doing a good thing. So thank you so much for watching this video. Take care.